In this example, I need to verify the identity when I have the cosecant of x divided by the cotangent of x minus the cotangent of x divided by the quantity 1 plus the cosecant of x equals the tangent of x. Remember, in identities, we want to work on one side and show it equals the other. And we often start working on the more complicated of the two sides, which in this case obviously is the left-hand side. So I'm going to start working on the left-hand side, and here are a few useful identities that might help me solve this problem. Now, looking at this identity, how many trig functions are present? I have three: the cosecant function, the cotangent function, and the tangent function. So one method to use when you have a lot of different trig functions present is to write everything in terms of sines and cosines, but that is often a longer method. Is there a more efficient method in this problem? Well, looking on the left-hand side, it only involves the cosecant function and the cotangent function. And there is a Pythagorean identity involving both of those functions. So what I'm going to do is I'm going to work on the left-hand side. I have two terms. I'm going to combine them over a common denominator and then see if I can use this Pythagorean identity. So looking at this problem, I need to find the least common denominator. To do that, you go to the first denominator. I need the cotangent of x. Go to the second denominator. Do I have a 1 plus cosecant x in my LCD? No. So I have to multiply by 1 plus the cosecant of x. So now I'm going to write both these terms over the common denominator. So I'm going to get the cosecant of x divided by the cotangent of x. And then to write it over a common denominator, what's missing in this denominator? I need to have a 1 plus the cosecant of x in the denominator. So since I multiplied the denominator by that term, I must multiply the numerator by the exact same expression, because all I'm really multiplying by here is 1 in disguise. Now for my next term, I have minus the cotangent of x divided by the quantity 1 plus the cosecant of x. And in this expression here, what's missing in the denominator? I don't have a cotangent of x, so I'm going to have to multiply both the numerator and the denominator by the cotangent of x, because all I'm really multiplying by is 1. So looking at my two denominators, is this denominator the same as this one? Yes, multiplication is commutative. It doesn't matter if I write it this way or this way. I'm just going to write my denominator as the cotangent of x times 1 plus the cosecant of x. Working on my numerator, the cosecant of x times 1 is just the cosecant of x. The cosecant of x times the cosecant of x is going to give me plus cosecant squared x minus the cotangent of x times the cotangent of x is cotangent squared x. Now, looking at these two terms here, is this Pythagorean identity going to be useful? Yes. If I subtract the cotangent squared x from both sides of this identity, on the left-hand side, these add up to 0. I get 1 on the left-hand side equals on the right-hand side cosecant squared x minus cotangent squared x. So I know this expression up here is just equal to 1. So my numerator becomes the cosecant of x plus, this expression is 1, divided by the cotangent of x times 1 plus the cosecant of x. Can I simplify that? Yes. This expression in the numerator is exactly the same as this expression in the denominator, as addition is commutative. So these will reduce. I get left with 1 in the numerator divided by cotangent of x times 1 in the denominator is just the cotangent of x. And what is 1 divided by the cotangent of x? Remember, it is the reciprocal function of the tangent of x. So this is going to equal the tangent of x. But just to prove it, I'm going to write it up here. I'm going to write my numerator 1 as a fraction, 1 divided by 1, divided by the cotangent of x, which is 1 divided by the tangent of x. How do we divide fractions? You take the fraction in the numerator, multiply it by the reciprocal of the fraction in the denominator. The reciprocal of 1 divided by the tangent of x is the tangent of x divided by 1. And so that's going to give me 1 times the tangent of x divided by 1, which is just the tangent of x, and that equals the right-hand side. So I have verified this identity.